Hello everyone. In this video we're going to be solving a nice exponential equation. We've done similar problems before, and let's go ahead and take a look at this one. So we have 2 to the power 3 to the power 4 to the power x equals 4 to the power 3 to the power 2 to the power x. So one of the exponents is kind of like ascending, going up, the values are kind of going up, and the other one is going down, and those are the same numbers. But one of the things that makes this problem really nice is the fact that we have the 2 and the 4 at the bases, so that we can kind of find the relationship between them. All right, great. So let's get started. I'm going to go ahead and start by writing the 4, which is the base here, as 2 squared. The left-hand side is going to stay the same for now, 2 to the power 3 to the power 4 to the power x. By the way, when I say something like a to the power b to the power c, it may not be always clear, but what we mean is a to the power b to the power c taken together. So if you want to write a to the power b to the power c, we're going to use parentheses, and this would be equivalent to a to the power b times c. In this case, b and c are not multiplied, rather they are bases and exponents. Make sense? So those are two different things most of the time. And now we're going to go ahead and write the 4, this 4, as 2 to the second power, because that's what it is, right? 4 is 2 squared. Awesome. Let's go ahead and take care of the rest. To the power 3, to the power 2, to the power x. Great. Now we have more exponents on the right-hand side, but that's okay, because now we have the second situation here, this one. So we can kind of multiply b and c, the exponents. The exponents here are, one of them is 2, the other one is this one. So we're going to multiply those two together. Make sense? So we're going to get 2 to the power 3 to the power 4 to the power x equals 2 to the power 2 times 3 to the power 2 to the power x. That's what we got to do. Multiply the exponents. It's called the superpower property, or the power of a power property. Okay? Cool. So far we got this. And one of the things that's really nice is basically, and I don't think I need that ruler. I don't know how to get rid of that, by the way. I'm trying to undo it. I guess we could probably remove this off the screen. Anyway, something like that. So we get 2 times 3 to the power, let me rewrite it, 2 to the power x. Okay, I don't know how the ruler came up, by the way. Anyway, so we get this expression now. The bases are equal. Notice that here we have the same base. So we can go ahead and set the exponents equal to each other. Make sense? So that gives us 3 to the power 4 to the power x equals 2 times 3 to the power 2 to the power x. Now, exponential equations come in different flavors, and sometimes they can be quite complicated. Now, in this case, we're kind of looking at the right-hand side, and 2 and 3 are different bases. So I can't really multiply them, right? There's no way to combine those two expressions, that product, into a single exponential number. But one of the things that you should notice here is, once we write the exponents, then we have the same base one more time for these two numbers, 3 and 3. So that's what's really cool about this problem, is that as you solve it, you end up with the same base, and you can continue to simplify it. If we had different bases, obviously it will be a total different story. So now we can go ahead and divide both sides by 3 to the power 2 to the power x, and that would give us a 2 on the right-hand side. And now we are dividing two powers with the same base. So what does that mean? It means we can subtract the exponents. Remember the property of powers or exponents? If you divide a to the x by a to the y, you get a to the power x minus y. So if you divide two powers with the same base, you subtract the exponents. Make sense? Easy, right? So from here we get 3 to the power 4 to the x minus 2 to the x, because those are the exponents, equals 2. And again, we have a different base on the right-hand side, but don't worry about it, because we can use logarithms at this point. Because what we end up with here is we got a single variable exponent, which we can bring down by using logs. Make sense? Okay, cool. The rest should be fairly easy, in other words. So which base do you use? It's totally up to you. You can use base 3, you can use base e, which is the natural log, so on and so forth. But I think I'm going to use the natural log here. So let's use ln. ln both sides. And then the story doesn't end there, so we still gotta go through this. There's gonna be a little bit more to it. So now we can go ahead and bring this whole thing down as 4 to the x minus 2 to the x multiplied by ln 3 equals ln 2. So we just use properties of exponents, logs. Something like ln a to the power x can be written as x times ln a. So if there's a power, you can bring it to the front. Okay, now what did we get? Let's find out. Divide both sides by ln 3 and you got yourself a quadratic equation. Uh-oh, that's not good. We can solve it, don't worry about it. So now for this one, I'm going to use a very, very powerful method, which is called substitution. So ln 2 over ln 3 is a constant, and let's use k for constant, right? Constant. Is that how you spell it? No, that's actually with a c. But anyways, you get the idea. This is k is a constant. And let's go ahead and call this y. And hopefully you know why, because I chose it to be y. And 4 to the power x becomes y squared minus y equals k. We oversimplified the problem, obviously, because we just use variables, but don't worry about it. This makes solving the problem a lot easier, because now you got a very simple quadratic. Let's solve it. Y equals negative b with the quadratic formula, plus minus the square root of b squared, which is 1, minus 4ac, which is 1 plus 4k. And k is a numerical value, remember, divided by 2. Great, we got the y value, but k is a constant, y is a variable, and we have to back substitute. What is y? Y is 2 to the power x. Let's go ahead and back substitute, and we're just going to leave it at k for now. Now here's the thing that I want to talk about. We get two types of solutions from here. One of them is going to be 2 to the x equals 1 plus the square root of 1 plus 4k over 2. And the other one is going to be 2 to the x equals 1 minus square root of 1 plus 4k over 2. Now notice that this expression is actually, and I gotta kind of move it closer to this one so that I can indicate that this is actually less than 0. Yes, unfortunately, this is greater than 1 because k is positive. How do I know that it's ln 2 over ln 3? Obviously, it's positive. It's a constant and it's positive because ln 2 and ln 3 are both positive. So this is negative. And 2 to the power x cannot be negative for real values. If you want to solve complex solutions, you can, but I'm just going to stick to the real deal here. So 2 to the x is this now. You can go ahead and ln both sides one more time. ln 2 to the x equals ln 1 plus the square root of 1 plus 4k over 2, and then bring the x down, and you're gonna get the answer from here. Let's go ahead and write this here, because next we're gonna divide both sides by ln 2, and that's gonna give us the value of x. Make sense? Let's go ahead and erase it so it looks cleaner. This is going to be the value of x, which we were looking for, right? And obviously you can replace k with something which is, let's do it. What was k? ln 2 over ln 3, the square root of ln 1 plus 4 ln 2 over ln 3, and then that divided by 2, and that's going to be divided by ln 2. Obviously, you can simplify this if you want, but that's not super duper necessary. And guess what we're going to look at next? The answer from Wolfram Alpha, which pretty much coincides with our answer if you do the simplification. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.